Math 2, 10.5. Today we're talking about rationalizing expressions. What that means is, in any problem, if you have a root in the denominator, it is not an okay answer. Okay? And so what happens is we call it rationalizing the denominator. And so anytime there is a root in the denominator, we have to rationalize it. Okay? So we're just going to make a note to ourselves here. You cannot have a root in the denominator. Okay, so how could I get rid of that root in the denominator? What would be the one thing if I were to like multiply this? What would be the one thing I would need to multiply by in order to eliminate the root? Albert. A square root of 7 on this one, right? Because if I had a root 7 and a root 7, that makes a pair of 7s, right? Which would just make the number 7. Okay, but if you do something to the bottom, you always have to be fair, and you also have to do it to the top. And if you think about this, what is root 7 divided by root 7? 1, right? And you can multiply anything by 1 and it actually doesn't change it, right? And so all we're doing is kind of rewriting this problem or answer in a different way, okay? So root 7 times root 7, I'm just going to circle that because that actually makes a pair of 7s. And so now I have a 7 in the denominator. And then what is 1 times root 7? Root 7. And so that is my answer. So once you don't have a root in the denominator, you're fine. But remember, you can't just multiply the bottom by root 7. You have to be fair, do it to both. And when I do it to both, you can see that I'm really just multiplying by 1. And you can multiply anything by 1 and it actually doesn't change it. Okay? What do I do on number 2? Root 11 this time, right? So we're going to multiply by root 11 to both the top and the bottom. So what happens to the bottom here? Good. You have a pair of 11s now. Good. And on the top, see how the 3's not in the root? So it doesn't go in the root. Okay, so numbers that aren't in roots stay out front of the root, and numbers that are in the roots would stay in the root. So this is going to be 3 root 11. Now that I have these numbers out front, if I was able to reduce 3 and 11, I would, because both those numbers are not in roots, but 3 and 11 can't reduce. So that is my answer. Okay, 3, I'm going to give you about 30 seconds to try that one on your own. Once you get your answer, check in your group with somebody next to you, see if you guys agree.
My pencil. Keep losing it. It keeps falling. I don't know. I need to put my stuff back. Ew, this thing smells so bad. Can you smell it?
I don't want to either.
Ooh! It's like wet grass smell.
Okay, so what am I multiplying by? Thank you. Root 13. And whatever I do to the bottom, I also do to the top. And the root 13s on the bottom make a pair, which is just 13. And on the top, we have 5 root 13. Very good. Okay, now number 4, things slightly change. Please notice on some of these that we have now a root on the top and a root on the bottom. Okay, remember how I said if numbers were both outside of the root, you could reduce them? If they're both inside the root, you could also reduce them. Okay? And so I'm going to write a little note here. Reduce if possible.
Found it.
And you can reduce inside roots and outside roots. and I'm going to put separately. Okay, so right now there's no numbers outside the roots, but inside the root, can I reduce here at all? Yeah, what can I reduce by? 2, right? So the 2 cancels out, and then 2 goes into 18 how many times? 9. When you cancel out the 2 on the bottom, there's really a root 1 there. But what's the square root of 1? 1. And do we have to, if we have a 1 in the denominator, do we have to write it? No. And so if the bottom number eliminates, then that root's gone, it's gone. You can put it over 1 if you want to, but it's not necessary. And so now how would I end up simplifying this one?
3.
Very good. 9 breaks down to 3 times 3, so I have a pair of 3, so my answer is 3. Okay, anything that needs to be reclarified on that problem? Okay, what do you notice about number 5?
Divide by 3.
Good, we can divide by 3 to both the top and the bottom. Do we all agree with that? Okay, so 3 goes into 12 how many times? 4, and 3 goes into 15, 5. So right now I have the square root of 5 over the square root of 4. Now, while I have a root in the denominator, I would suggest always simplifying if you can. And if you notice, the square root of 4 can be simplified, right? What does it break down to? 2 and 2. And so I have a pair of 2's. So I end up with a 2 in the denominator. Do I now have a root in the denominator? No. So I don't have to worry about rationalizing the denominator. This is my answer. Okay, any questions on 5? Number 6. What will I do first on number 6? Simplify. What can go into both terms? Very good. So 5 goes into 13 3 times, and 5 goes into 25 5 times. Very good. So right now, I'm going to rewrite this. I have root 5 over root 3. Is that okay? No. What's wrong? We have a root in the denominator, so we need to rationalize the denominator. How do I do that? Very good. Multiply by root 3 to both the top and the bottom. When I do that here, I get a pair of 3's. So my denominator becomes 3. On the top, could I break down any of these to make a pair? Nope. So we multiply them together, and what do I get? Root 15. Now, could I reduce this 3 and the root 15? No. Why not? Very good. One of them's in a root and one of them's not in a root. They have to both be outside of a root or both be inside of a root in order to reduce. Okay? So that's my answer. Okay. Number 7. Are we ready? Any questions before? Okay, so on number 7, it's just written differently. Now, again, if I could reduce this fraction under the root, you would. Okay, in this case, 2 and 5, can I reduce them? No. Okay, you can rewrite this now, though, to just be root 2 over root 5. So when you have a big root with a fraction, you can separate them so they're both under roots. Okay? Now, is this an acceptable answer? No. What do I need to do?
Multiply by root 5.
Very good. Multiply by root 5 to both the top and the bottom. Okay, my denominator then becomes, very good, and the top will be, very good. Can I reduce the 10 and the 5? No, why not? Good, one's in a root and one is not in a root. Okay, they have to both be under roots or both not in roots. Okay, I'm going to keep asking you these questions because hopefully the more times you think about it, you will remember. Okay, number 8. Can I reduce 36 and 7? No. What should I do now? Okay, so write them as separate roots. Okay? We have root 36 over root 7. Can either of those roots be simplified?
No.
Try again.
Yes. 6 times 6.
Good. 36 can be reduced to be 6 times 6. If you simplify first, it will make your life easier. Okay? And so, right now it's going to be what?
6 root 7.
Very good. 6 over root 7. Now, is this an acceptable answer?
Yes.
No, why not?
Because the root 3.
Very good. You can't have a root in the denominator, and so I have to rationalize the denominator, and we do that by multiplying by root 7. Whatever we do the bottom, we do the top. This makes a pair of 7. So what will my answer now be?
6 root 7.
Okay. Can I reduce these 7s?
No.
No. Why not?
1's a root.
Very good. Can I reduce 6 and 7? I could, if I could, but they don't reduce, right? Okay. Number 9. What should I do first? Very good. Reduce, simplify. What can go into both 15 and 10? And so this becomes a 3 and this becomes a 2. When I rewrite it, I would, good, root 3 over root 2. Is that an acceptable answer? What do we do?
Multiply by root 2.
Very good. We get a pair of 2s, so my final answer on this one will be... Okay. Questions?
Also, do you have any